Hi, families, and welcome to Class 8. We're going to talk about Jean-Baptiste Lamarck. And I wanted to start by saying that I never thought that Lamarck got a fair shake, at least in my biology education. And I really didn't appreciate what he was trying to do. So I'm going to try to give him, I think a fair hearing, and I'll be curious to get your feedback. So let's dive in. Okay. Now that we have Lyle and time as a correlative variable, I wanted to keep using it. So just to remind you where we are on the timeline of biology, we're going to be in the early 19th century. Lamarck published probably his most famous work, Philosophie zoologique, in 1908, or sorry, 1809, excuse me. And so a couple decades, a couple Gracie footsteps, or a couple Gracie lifetime footsteps, before Lyell and Cuvier. As I recall, I think Lyell mentioned both Lamarck and Cuvier in his writing. So yeah, and just another view in our actual walk through the history of biology, Lamarck would be right about there. So now just to remind you of the timeline of our herbarium, right? Last time we were faced with the question of, okay, if you see algae for since about 1.6 billion years ago, but you only see moss around 500 million years ago, and then you only see club moss and ferns around 420 million years ago, and you only start to see seeded plants around 350 million years ago, and then flowering and fruiting plants 150 million years ago. How did they come about? And I was actually thinking I could really only come up with two potential hypotheses. And one of them is that, like we can see that the differences between algae and the land plants is that algae don't really grow on land. All they need, water, sunlight, nutrients, a place to propagate their kind, are all in the same place. Whereas land plants, they're all in different places. So they need to find a way of like bringing water to the top where the sunlight is and bringing the nutrients they make from the sunlight down to the bottom. And, they need a safe place for their spores to propagate. None of that is trivial. And at each step, from moss to club moss and ferns to seeded plants to flowering plants, adds like a new and better kind of biological technology for doing that. So it seems like there is an addition with each stage. So the question is, do they come up with some physiological adaptation that becomes heritable, or do they suddenly have something new that is heritable that leads to a new physiological adaptation? And those were really the only two hypotheses I could come up with to explain the evolution of plants over time. So if you have another idea, another hypothesis for how this could happen, you adapt, and then your adaptation is, inherited by your kids, or you have um, some new feature that of inheritance that you give to your kids, and that gives them an adaptation. Those are the two hypotheses I'm kind of thinking of. If you can think of another one, I would love to hear it. So please put it in the comments. So don't want to overlook any potential hypotheses. Okay, so what let's kind of go back and appreciate what Linnaeus did, right? So we had a few examples of different species. One of the things that Linnaeus did was just add a lot more observations, and with the help of his students and colleagues. And that really helped us to start to see the similarities within groups of species and the differences between groups of species. So he started creating those correlations, right? He could see there's something um, similar between different algae, for example, that was uniquely different from moss. So he started not just adding a whole lot of species observations, but then starting to group them and correlate them into different genera. That's the plural of genus. Um, and Lamarck really added to that. He started seeing correlations between genera and started grouping them into families. Um, so, for instance, there are some similarities between club moss and ferns and seeded plants and flowering plants, right? They all have true leaves with veins in them. They have, like as you're getting to ferns, you're starting to see stems and roots that you don't see in moss and algae, for example. So, and then he even went further and started seeing similarities between different families and in grouping them into orders. So he was really starting to get a sense that like all life is connected in some way, that there are similarities if you keep kind of grouping and grouping and grouping, that all life has certain similarities. And that really gave him the idea that all life may have come from an initial beginning and started to change and diversify in the same way that like your grandparents are sort of the beginning of your parents and aunts and uncles, who are different but similar in certain ways. And then there's you and your cousins, and you're similar in certain ways but also uniquely different. And that could lead to changes, like significant changes over time. So here was Lamarck's idea for how this happens. So imagine you've got a fictional predecessor of a giraffe. We'll call it an araph. And it's kind of got like a short neck, right? But it's pretty tall, and it eats, sort of leaves from the higher branches of trees. So you've got, this araph over here, and there's another araph over there. And the difference is that the araph on the left is, just kind of going along to get along, and the araph on the right is trying to live their best life. You know what? They're going to reach for those higher branches. And so Lamarck's idea was that like the araph on the right stretches their neck and starts reaching for those higher leaves. And then once their neck gets longer, they start having kids, and those kids now have slightly longer necks as a result. And, so you've got like a group of arafs who just kind of go along to get along, and they, just go for whatever branch is, easy to reach. And you've got these B-rafs, this is kind of like starting to speciate, that are growing longer necks, and they grow, they reach for those higher branches. They try to live their best life. Um, and and then that adaptation, that physiological adaptation, is inherited by their kids. So what would that mean in terms of your timeline of your herbarium? Well, it would mean that if you looked at enough individuals of each species of algae, you might see some of them trying to kind of creep onto the shore of whatever pond or ocean that they're living in. And you might even see them, they'd have to make some adjustments, right? Because they're used to living in water, but maybe they actually start to create sporophytes. So one of my lovely commenters and students asked, do plants have babies? And I am here to answer the question now. If you look at your moss samples in your herbarium, you might see that you've got your moss, it kind of look like leaves, even though they're not. And some will have like this stalk kind of sticking out of those leaves and like a little sort of round tip at the end, that's actually the baby. You're seeing two generations there. You've got the gametophyte generation, which is kind of like the parents, and then you've got the baby generation, the sporophyte. Now, there's a lot more to be said about alternating generations in plants. It's actually pretty amazing and weird. But they have these sporophytes that are meant to sort of drop into the water, the moisture, and mix with the spores of other moss plants, other moss plant individuals, and start a new gametophyte generation. So, if we're thinking about a physiological adaptation, you might be looking for moss that's actually got one of these little stalks coming out so that it can spread its spores to places that are moist but not necessarily fully immersed in water. And indeed, you'd expect, based on Lamarck's hypothesis, that you'd see, like, so if algae had been around for 1.6 billion years, it may take, over a billion years for these physiological adaptations to get you all the way on land into moss. But you'd expect, I think, based on Lamarck's idea, that that's always happening. That the algae today, some of those individuals in each species is kind of moving in the direction of making new mosses and new moss species. And if we take that further, there are mosses that are in the state of like BRAF or CRAF or DRAF, kind of like starting to make genuine leaves or genuine roots, more like club moss and fern. And if you look at enough club moss and fern, you might see them starting to create protected seeds that can blow in the wind or open up in fire, right? More like the seeded plants. And you might even see the gymnosperms trying to make flowers continue. So you'll have like a whole population of like some ARAFs and some BRAFs and some CRAFs, and of course we see a lot of giraffes. Anyway, it's a ridiculous pun. But so what we're gonna do like you can tell that it's not obvious. If we think that all life is connected, and we have pretty good reason at this point to think that all life is connected in some way, and yet, hearkening back to our first class, right? We know that acorns never make anything but oak trees, and beans never make anything but beanstalks. So they all seem connected in some way, and yet, where do these species come from? It's not obvious. And that was Lamarck's attempt to kind of explain where they came from. Now, we're going to do something that, as far as I know, Lamarck never did. And that is that we're going to test it. And I know what you're thinking, like, how, if like these speciations happen over the course of hundreds of millions of years, how are we going to test it? Nobody has that kind of time. But in fact, we are in the process of testing it right now. So once you're done with the assigned reading, head on over and I'll explain the assignment where we're going to test Lamarck's hypothesis.